Last class I talked about here mapping to table. From table we move to a relational database. I shown what is attributes with tuples with a relational name. Then I told about characters of relation where you want to maintain the order of attributes, order of tuples, meaning of a relation and entering null values. This has been discussed in the last class, right? So, we told about entire things of relation database, and I also told the drawback of relation database, right? So, as a BE course concern, you people are learning our relation database. As a concern of syllabus, we are going to learn a relation database. Nowadays, we moved up and we are using object-oriented database as one of the main area where we are working with combination of C++ and Java with DBMS, okay. So, now I will move to relational constants, relation model constants. I need to move on. So, relational model constants. So, relational database constants that I need to move on. So, relational model constants. So, relational database rules I can tell it out. So, rules you need to follow on a particular table comes with a relational model constants, okay. The first constant says domain constants. The first constant is domain constants. Domain constants. The first one is arises with domain constants, okay. You need to define a domain for a table of an attribute, okay. So, table of attributes must be defined with a domain, So, I will tell domain of A. I am speaking about a domain of attribute with how I can specify using data types, okay. So, domain of A, okay. So, domain of an attributes specified with data types, So, if I tell domain of SSN, So, SSN can be defined with, as you know, SSN or a USN comes with varying character data types. So, DBMS has different data types that contains, right. So, we have varchar, right. We have integer, we have float, we have character, right. We have character, we have date, we have time, we have blob, binary larger object, we have slob, character larger object. So, these are the sum of the data types that required to define a domain of an attribute, okay. So, for example, if I told domain of an SSN, SSN is a mix of integer and a character. It's a mix of integer and character. This comes with a domain, right. So, domains defined with SSN, where I don't define with the data type called varying characters because of it contain integer and a character, right. So, now I am going with domain of SSN. So, SSN can be defined with data type varchar. So, varchar length of 20. So, SSN is a attribute of an employee database. So, employee database SSN defines with the data type length is 20. So, length is I am defining a length of an attribute can be where you enter the tuple, it can be length of 20. I am giving on. So, if I consider length as USN, it comes with a 10, okay. So, I define USN with USN attribute. So, domain of USN with the varchar 10, I can define this. So, if for example, I want to define name, I want to go with the domain attribute of a name. Name comes with character, because name has only the character can be defined with the length of character. Then there is, if you want to define salary, you can go for float. If you want to define your age, that goes for the integer. Then you want to define, if I want to join a particular institution, then comes with a date, time, at what time you join a particular institution on a particular date, right? Then there is a binary ledger object and catalog object to define the data types of images. Where you want to work on images, that time you required what I call as blob and slob with a binary ledger object and catalog object. Okay, so most of the times in lab or in DBMS lab, or to define any data types or any attributes, we use this number of data types for an DBMS, through domain constants, So this is called domain constants. This is what? The domain constants that can be applied for to define the structure of a database or to define a table of a database, can be done through domain constants through various data types like varying character, integer, float, character, date, time, and blob and slob. Okay, so next one. So this is one thing. Next one, we go with key constants. We go with key constants. So we have various keys are available to define with what I call as keys, because keys plays major role in any table. So any table, it plays major role. Key is one of things can be uniquely identify. One of things to uniquely identify a tuple. A tuple in the relation is called key, which is uniquely identified. Key is nothing but an unique property that uses it to identify uniqueness of a tuple in a relation is called key. Okay, it's called an key. The first one I like to discuss is super key. Super key. So what is super key? So name itself tells that super, right? Name itself tells that it's super. Super means it must be a powerful, right? It must be a super powerful. A powerful man or a Superman, actually Spider-Man, Superman we call as, right? Because of they can do everything. Like that we have a super key. Which can uniquely identify. For example, in an employee database, I consider SSN is the property of an employee table which uniquely identify a tuple in a relation. SSN is the main property, is key, right? It's a key that uniquely identify a tuple in a relation. Okay. So for example, now if I go for account section and ask for any student details, they will ask for USN, right? They will ask for USN. It's a unique because it's a uniqueness property. So I'll name SSN with a name and make it out. I'll make it out SSN with name. So I will tell my USN, then I will tell my name. So it become more uniqueness, right? So if I tell super key what SSN with the name, so it makes more uniqueness. SSN adding with the name contain and more uniqueness property Then I will add age. Something I need to identify employee in a database. Still I need to make it more uniqueness property. I'll tell that person maybe 35 years young, it look like this. He's maybe 35 years age with the what I call SSN with the name, it look like that. So it become more powerful, right? It contain more powerful. So SSN name. Then I will tell if I go for which department is maybe working. Which department he may be working. So still I want to identify. I may tell, he's working for in the department of ISC. So SSN name department, so that it become still more uniqueness, right? It become more uniqueness. It become more uniqueness and more uniqueness property. So we are trying for various combinations. So then I will try for maybe I will tell, so this person with a name in SSN with a person with a 35 years age come from Mandya. Address of Mandya. So Mandya is coming from, he's the age of 35 years, he is working for ISC department, with SSN, with the name, it's become a fantastic uniqueness property. It become a fantastic uniqueness property. Like this, we have n number of combination. Like this, we have n number of combinations. Okay, n number of combinations to identify uniqueness property, to go for identifying a tuple in a relation, right? Tuple in a relation. Okay, so this is what is this. So I write a definition for super key. I told this is the combination you can try, various combination you can try it, SSN with a name. So SSN with a name, SSN name with the age, SSN name with the department number, SSN name with address, age with the address, right? It make more uniqueness property. So how can I write a definition for this? How can I write a definition for this? Okay, super key. Super key is nothing but a set of attributes. A set of attributes or a combination of attributes, a set of attributes or a combination of attribute that uniquely identify the tuple in the relation is called super key. Is called a super key. A set of attributes. Maybe I am correct, right? So this is a name, age, it's the name, department number, it's the name, address. A set of attributes, right? A set of attributes or a combination of attributes that I am doing. A set of attributes or a combination of attributes that uniquely identify tuple in the relational is called super key. Is called super key. See, did I done anything by it? Nothing like that. Just I told a thinking way, simple way, that a combination of attributes in a database that uniquely identify the tuple in a relation is called super key. It's called super key. That's what we done, right? A simple way, right? Or a set of attributes that uniquely identify a tuple in a relation is called super key. It's called super key. It's called super key. We have n number of combinations. That uniquely identify tuple in a relation is called super key, right? We have a number of combinations, right? SSN name, age, SSN department number, age, the address. Then I come with some more attributes, right? Some more attribute combination can try it out, right? So that makes more uniqueness. That make more uniqueness property. That is called super key. That is called an super key. Okay, that's called a super key. Then what is next one? So we come up with a good to identify uniqueness property. Then now I'll move to candidate key. So we learn about super key now, because it tells that the set of attributes that uniquely identify tuple in a relation is called super key. Now candidate key. Okay, so candidate key. So I want to link super key with a candidate key with a primary key, right? So this combination works well. Okay, combination works well. So candidate key. What is candidate key? Candidate key is a minimal set of super key is called candidate key. Easy way definition. Which is minimal set here. So I have various combination, right? SSN name, age, SSN name, the department number, SSN name, age, the address, right? I have various combination. A minimal set of super key is called candidate key, CK what we call as, right? So minimal set is SSN name. So minimal set of super key is called candidate key. A minimal set of super key is called as candidate key. Is called as an candidate key. Is called as can be called as an candidate key. Okay, it's called as candidate key. Okay, so see here the SSN and name can be picked as candidate key. Can be picked as candidate key. Okay, so SSN comma name can be called as candidate key. Okay, candidate key. So now it comes with the super key combinations, then it comes with a candidate key. Okay, now I'll move to primary key. I'll move to an primary key. Okay, so minimal set of super key is called candidate key. So I'll move to primary key. So what is primary key? What is primary key? As I told, I discussed a lot of introduction classes. I told about why the property of primary key is needed, right? Because of it uniquely identify a tuple in the relation. It's uniquely identify a tuple in the relation. That's primary key. It's a primary. It talks about primary initially. Yesterday I told about characteristics of relation where employees SSN, student is a USN. It's a primary key, right? Because it starts with the uniqueness property. That's what we told as a primary key. So here it comes with the combinations. A minimal set of super keys called candidate key. So one of the candidate key can be called as primary key. One of the attribute in a candidate key can be called as primary key, right? So primary key is nothing but a uniqueness property. It holds. One of the candidate key can be called as primary key. One of the candidate key can be called as primary key. So one of the candidate key is called as primary key. One of the candidate key is called as primary key. Is called as an primary key. Okay, you can see that one of the candidate key is called as an primary key, right? So now SSN this can be called as primary key. What is that name? So SSN we have. Then name can be other than candidate key, other than primary key, can be called as secondary key. Can be called as secondary key. Okay. So here SSN is primary key. Other than primary key, it can be called as secondary key. That is name. That is name. So minimal set of super key can be called as candidate key. One of the candidate key can be called as primary key. Other than primary key can be called as, which is attribute, because other than primary key can be called as secondary key. Can be called as secondary key. Okay, secondary key. Okay, this is what say SSN has been identified as a primary key. Other than primary key can be called as secondary key. Can be called as secondary key. Okay, so this is what the keys tells, right? So primary key I told comes with what I call as secondary key with other than primary key. Then we moved, see, we start with the super key, a combination we tried. Then we come with minimal set. Then one of the candidate key can be called as primary key. Other than primary key can be called as secondary key. What a simple way started, right? So if I can see the books, so I can refer, a lot of books are available. A lot of Google sites have been able to understand the key concepts. So when I started the first time when I was teaching about the what I call as a DBMS with the key constants, I got a lot of confused because I do not know which is super key. I was thinking, oh, this combination may work. I was studying a lot of things. Later part I more think of understand with reading various books and Google sites. I made it a different definition with the beautiful examples. Okay, so different definition with the beautiful examples. So I decided to go with a fantastic way of analyzing a super key, what you call as candidate key, then primary key, then secondary key. Okay, the combination must go on because the variable you people may think, okay, like this. No, it is must be arises from super key where combination, then minimal, then take one, then take other to go for keys. Okay, so this is one of the way of understanding the super key, kinetic key and primary key with the secondary key. Because a lot of time, in exams, people will ask a lot of questions arises. A lot of times, lot of question paper contains what explain key constants in relation database. Explain key constants in relation database. Then you can write a simple approach. Then you can write a simple way to approach or a simple way to utilize your English to give a beautiful definition for super key or a kinetic key or a primary key with secondary key. With a secondary key. Okay. Then we have foreign key. We have foreign key. We have an foreign key. So what is foreign key? There's one of the things is foreign key. Okay, foreign key. So foreign key, as I told, it has maybe like this. We'll take example of employee table. Employee table and let's take department table. So department number, department name, department number, department name, what? SSN, name and D number and D number and D number. Okay, and then D number. So employee having a key called SSN, department having a key called department number. Okay, department number. Okay, so my job is to define foreign key. Okay, so employee, it's a table relation database containing SSN, name and D number. So this D number, what this D number contains, it refers department relation table or department table primary key department number. Okay, an attribute of relation R1 refers to the primary key of relation R2 is called foreign key. What simple way, right? An attribute of relation R1 references primary key of relation R2 is called foreign key. Is called an foreign key. Right? So here we have employee, so SSN, so name and D number, so it's attribute. So attribute of employee table refers to the department of primary key called D number, then it's called foreign key. Then it's called an foreign key. An attribute of relation R1 refers to the primary key of relation R2 is called foreign key. It's called an foreign key. Okay, that is a small definition. An attribute of relation R1 refers to primary key of relation R2. The attribute of relation R1 refers to the primary key of relation R2 is called foreign key. Is called an foreign key. Is called an foreign key. Okay. So this is way of understanding the keys. Understanding a beautiful keys, right? So it shows that how it works, right? It shows how simple it is, how it works, right? So attribute of relation R1 refers to the primary key of relation R2 is called foreign key. Is called an foreign key. Is called an foreign key. Okay. So this is about how the keys, super key, kinetic key, primary key, secondary key. Then we come across foreign key. Come across an foreign key. Okay. Then I have some entity constants. Some entity constants. Some entity constants or relational constants or some entity constant what we talks about. Okay, what we talks about. So entity constants. Entity constants, you have two types. You have two things, two rules that define on a particular table. So two rules that define on a particular table. Two rules to define on a particular table. That is entity integrity constants and referential integrity constant. Okay, entity integrity constants entity integrity constants and referential integrity constants. So here, entity integrity constants tell that rule that define that primary key cannot be null. It defines that primary key cannot be null. So employee is a table name containing SSN, containing name, containing department number, defines with primary key 11, 22 and null. So SSN is a primary key of employee database, tells that primary key must not be null. So entity integrity tells that primary key cannot be null. So if it is null, for example, a student without USN, it is possible to continue bachelor degree in EBTU? No, right? So every student must have unique USN code because you want to write the exam, you want to get the results, you want to get all the details, right, of your that you joined for particular organization with the based of your VTU, maybe based on university, right? So based on your USN, we're going to identify your details, right? Based on details, you're getting all the necessary information required, right? So your USN plays major role in your course through B, right? What are the branch it may be? So it plays vital role, right? It plays vital role while doing your degree, right? Like that. So without USN, it's not possible to get all details, right? It's very difficult to get your details without USN, right? You cannot able to search your results, cannot able to do exams, right? So lot of drawbacks, right? Without USN, if it is null, right? If USN is null, what another thing not able to exist in the world, right? Nowadays we also have Aadhaar card. Another uniqueness property to stay in our country, right? So that's defined, and so Aadhaar card defines your uniqueness property, right? So that uniqueness property cannot be null. So wherever you go, they will ask for Aadhaar card. Without Aadhaar card, you're not able to identify your belongingness, right? That's what. So primary key cannot be null. So if you put null, as I told, it is very difficult to go for reference because this is the attribute referred by various tables. If I go for tables wise, I can tell that employee SSN referred by department SSN, dependence SSN. So various table refers particular attribute as a primary key, right? That's what, right? It cannot be null. This tuple cannot be null. So primary key cannot be null. It must have uniqueness property. It cannot be null. It cannot be null. So that's what entity integrity constant tell that. The rule defines that. The rule that defines that primary key cannot be null. Primary key cannot be null. Okay? Primary key cannot be null. If it is null, then your existence cannot be possible in any of the database. Any of the database is not possible. That is called entity integrity constant. That is a rule that defines primary key. But write PK. Primary key cannot be null. Cannot be null. Okay. We have another rule. That is referential integrity constants. Referential integrity constants. Okay. We have referential integrity constants. Okay. So I will take example of again employee refers 1, 2, 1. Okay, other table. Then our other table, that is maybe D number with D name, defines with a department table, defines with a department table, defines with department table containing tuples 1, 2, maybe CS and IS are two branches. So I'll put 3 here. I'll put 3 here. So referential integrity constant. So I want to give definition for this particular thing says a tuple in a tuple of an attribute in relation R1. A tuple of an attribute relation R1 refers to the existing tuple of a relation R2. Refers to the existing relation of R2 is called referential integrity constant. It's called and referential integrity constants. So you can see that 3. So 3 goes for, if 3 exists here, we have 1 and 2. 1 and 2 branches are available. That is CS and IS, right? So only 2 branches are available, but I given 3 here. I given 3 here. You are violating a referential integrity constant. You are violating and referential integrity constant. Okay, you are violating a referential integrity constant. Okay, as I told, a tuple of an attribute relation R1 refers to the existing tuple of relation R2 is called a referential integrity constant. Is called a referential integrity constant. Okay, I want to make it as a 1. I want to make it as a 1 because of 1 and 2 branches are available, that is 1 and 2. That's what I made it 1, 2, 1. So this is refers existing tuple. That refers in existing tuple, that is called as a referential integrity constant. It is called as an referential integrity constant, right? So write a definition for this. Write a definition for this where a tuple of an attribute of relation R1 refers to the existing tuple of relational R2 is called an referential integrity constant. Is called an referential integrity constant. A tuple of an attribute of relation R1 refers to the existing tuple of relation R2 is called a referential integrity constant. Is called and referential integrity constants. Okay, so it's very easy to understand, right? Very easy to analyze that and understand that. Definition. So part of definition I just told what exists in a particular tables, right? Not think any written any textbook. Just I told that very simple way. A tuple of an attribute of relation R1 refers to the existing tuple of relation R2 is called referential integrity constant. Is called and referential integrity constant. Such a way that the entity constants are defined in relational constants. Such a way the entity constants are defined in relational constants. Okay, such a way that has been developed. Okay, we start with the domain constants. I told why domain require data type. We discuss about various data types. Then it comes with the key constants. Talks about a combination of attributes that makes super key. A minimal set of super key is called candidate key. One of the candidate key can be called as primary key. Other than primary key can be called as secondary key. Then we talks about foreign key. So foreign key means attribute of relation R1 refers to the primary key of relation R2 is called foreign key. Then it comes with entity integrity constant, the rule that defines primary key cannot be null. So if it is null, then you are violating entity integrity constant. Then you are violating an entity integrity constant. Then I comes with referential integrity constants, where I told about you must refer existing tuple of a relation R2. So attribute must, when you go for reference, it must exist. When you go for reference, it must exist. That is called a referential integrity constants. So these are the rules you need to apply for. You need to apply for tables while defining the structure of database. Okay, structure of database. So write small schema diagram. So small schema diagram with identified foreign keys and primary keys. Okay, so that it's easy to go on analyze what we discussed, what we done in entire class in a simple diagram. Okay. So here I am, as I told, I go for company, writing a company database schema. Okay. So employee, so one table comes with company database. Okay. So SSN, name, age, and D number. Okay. So then I have department, D number, D name, SSN. Okay. Then I have project, P number, P name, D number. Okay. So the table, that is project table. Then I have dependents. So dependents, SSN, dependent relation, that defines. Okay, so now my job is to identify primary key and foreign key in a given schema diagram. Okay, SSN, so then department number, then P number, or a foreign keys, or a primary keys, or a primary keys of a particular tables, right? So this is a partial key that contains by dependents as a weak entity part, right? Okay. So employees foreign key, this department number refers department number. SSN is other foreign key that refers in a table of department to the employee SSN. Then department number of a project table refers department number. Then SSN goes to refer the SSN of a strong entity, that is employee SSN, goes for with the dependents. So this is small diagram where I terms with identified primary key and foreign key in a given schema diagram. SSN with the name, with the D number as a foreign key, refers department table. SSN is a foreign key for department table, refers employee SSN. Then project, P number is a primary key, and D numbers, foreign key, refers to the department number. Depend is SSN, strong entity, is a weak entity dependence, refers to the strong entity that is called employee SSN. So this is the way of, a simple way of analyzing or identifying the primary key and foreign key in a given database with the various tables. Okay. Such a easy way to define and understand. Okay. So hope I made it to understand well the simple concepts, the simple way to understand the relation database with the relation constants. Okay. Next class I'll move to relation algebra, where it talks about the basic symbols that are required to define what you call as database with the queries to be applied for various tables. Okay. Thank you so much.